So today's lesson, we're going to go over the volume, and we're going to talk about the volume of cylinders and of prisms. So our objectives are to learn and apply the formula for the volume of a prism in a cube, and then also for the formula for the volume of a cylinder. So volume, the definition of volume is the measure of how much space it takes up. Volume is a measure of capacity, and volume is three-dimensional, whereas when we talked about area, it was two-dimensional. Volume is three-dimensional. So when we talk about volume here, we talk about the volume of a prism. We're talking about the length times the width times the height. So this bottom down part down here is the base. So when we talk about the volume of a prism, it's our base times our height. Over here, when we talk about a cube, the difference with the cube is all three dimensions are the same in a cube. So the side length of the width is the same as the depth, or the length is the same as the width as the height. So this time when we talk about the volume of a cube, we're going to cube whatever each side length is, or whatever each edge length is. So let's go ahead and look at a couple problems here. So here with example 1, we're going to find the volume of this prism. And we're going to round to the nearest tenth if necessary. So in this case, again, we have our formula is the volume is equal to the length times width times height. So our length is 9, our width is 4, and our height is 6. So we're going to multiply 9 times 4 times 6. When we do that, we're going to get 216. Now, one of the things I need to point out to you is that you should notice here that our unit is cubed. And that's because we multiplied a centimeter times a centimeter times a centimeter. And when we have centimeters multiplied by each other 3 times, that means it's centimeters cubed. So when we're talking about volume, our unit measure is always going to be cubed, whereas when we were talking about area, it's always going to be squared. So this next one says find the volume of a cube with an edge length of 8 feet. Now, once again, we know that the length, the width, and the height are all 8 this time because it's a cube. And all the sides of a cube have the same area and the same length and the same width and the same height. So we're going to cube now this side length of 8. And when we do that, we get 512. And again, you'll notice here that our unit, which was feet, is cubed. All right, so do this, check it out, and then come back to me when you're done. Okay, so now, when we look at this one again, we've got our length 12, our width 4, and our height 8. So we're going to multiply 12 times 4 times 8. When we do that, we're going to get 384 feet cubed. Next one, same thing. Go ahead and do this and then come back to me. So on this one, it says find the volume of a cube with an edge length of 15. Again, we know that the length, the width, and the height of a cube are all the same. So we're going to cube this number 15. And so when we cube 15, we get 3,375. And again, it was inches. That was our unit up here, inches. So we're going to cube that unit because we had 3 dimensions. All right, so our next problems have to do with prisms, or have to do with cylinders, sorry. So one of the things I want to point out to you is that the bottom of a cylinder is a circle. And this bottom part actually is the area of the circle. And when we're trying to find the volume of something, we multiply the base times the height. The base here is a circle, and the formula for the area of a circle is pi r squared. And then we're going to multiply that times the height. So if you notice here, it says the volume is base times height, or the volume is pi r squared times height. And on your formula sheet for a cylinder, it does have volume is equal to pi r squared h. Now, I also want to remind you that there is no formulas on the formula sheet for prisms and for cubes, so you're going to have to memorize those. Now, over here on this one, you should notice too that when this is slanted, we always have to get the height, which is a perpendicular from the base. So this is our height outside this drawing this time because it's slanted. So we need our height, which is perpendicular to the base here. Okay, so let's look at this first drawing here. It says find the volume of a cylinder. Give your answer in terms of pi and round it to 2 decimal places. So what we're going to do is we're going to go ahead and populate our formula. But I notice right here that our big problem here is in our formula is pi r squared h. Well, I see a diameter here, but I don't see a radius. So the first thing we have to do is find the radius. And we know that 12 divided by 2 is, this is the diameter. There's 2 radiuses in that. So we're going to divide that 12 by 2, and that gives us 6. So then we're going to square that 6, and we're going to multiply it by 10, which is the height. So our first answer is going to be 36 times 10, which is 360 pi. And again, that's feet cubed. And then when we multiply it by pi, it's going to be 1,130.97 feet cubed. Really important that you guys answer these both ways, with pi in the answer and multiplied by pi. Our next one. Now this one says find the volume of a cylinder with a base area of 121 pi centimeters squared and a height equal to twice the radius. So what I notice is it says that we have a base area here of 121 pi. So I want you guys to see what this looks like. So this is our cylinder, and it's telling us that this right here, which is our base, which is a circle, is 121 pi. We don't know the height. We have to find the height. So it says here that the height is equal to twice the radius. So if the height is equal to twice the radius, then we have to find the radius. So the first thing we're going to do here is find the radius. And the way we're going to do that is we're going to use the formula for the area of a circle. This is the area of a circle right up here. This is the area of that circle. So that formula is A is equal to pi r squared. So we're going to use that. And that means 121 pi is equal to pi r squared. We can see that pi is on both sides of this, so it's going to cancel out, or we could have divided it out. You should also notice that this is now r squared is equal to 121. So to find the answer, we're going to take the square root of both sides. So r is equal to 11. Now we have the radius, but we need the height. Up here in our problem, it said height is equal to twice the radius. So h is equal to 2 times the radius. So the radius is equal to 2 times 11, which is 22. Now as we work through the rest of this problem, we notice that we have the base here. So we have volume is equal to base times height. So volume is equal to base times height. We have our base, which is 121 pi, and our height is 22. So now we can go ahead and find our answer, both with pi, and we also know that this was in centimeters, so this is going to end up being centimeters cubed. So we can find our answer here with pi and with when we multiply by pi. So our answer when we multiply by pi is 2,662 pi centimeters cubed. And when we multiply 2,662 by pi in our calculator, we get 8,362.92 centimeters cubed. This next one, I want you to go ahead and do this and then come back to me when you're done. So here again on this one, we were given the radius, which is 3, and we're given the height. So we're just going to use our formula from our formula sheet. R is 3 here, and height is 5 there. So we're going to square the 3, which is 9, times 5. So that's going to give us 45 pi meters cubed again. Then we're going to multiply that pi in our calculator times 45. That will give us 141.37 meters cubed. Now here's another problem like the last one we did. I want you guys to go ahead and try this and then come back to me when you're done. Okay, so now, again, this is like the last one we did. We have a base of 25 pi. This time, we don't know what the height is. We're going to solve for it. So if that's our base, then once again, we are going to solve for the area, because this is a circle up here. We're going to use the formula for the area of a circle. So when we do that, our base is 25 pi is equal to pi r squared, because that's the area of a circle. We divide both sides by pi. We take the square root of both sides. The square root of 25 is 5. Now up here in our problem, if you notice, it tells us that the height is 3 more than the radius. So if it says the height is 3 more than the radius, then it's going to be 5 plus 3. That's our height. So our height is 5 plus 3. And so then we're going to multiply our base, which was 25 pi, times our height. That's going to give us 200 pi centimeters cubed. And when we multiply 200 times pi, we get 628.32 centimeters cubed. All right, now the next thing I want to talk to you about is this concept of when we change a measurement in a drawing. So when we change a perimeter or any length and we say that it's gotten bigger by some measure, like 2 times or 4 times, then we just multiply it by whatever that measure is. When we talk about area, however, because it's two-dimensional, if we say it got 2 times bigger, then we have to square that 2. If we said it got 3 times bigger, then we have to square that 3. Now, when we talk about volume, it's three-dimensional, so we're going to cube whatever that measure is. So if it said it got 2 times bigger, then we're going to cube the 2, which would be 2 times 2, which is 4, times another 2, which is 8. If it was 4, then we would cube the 4. 4 times 4 is 16, times another 4 is 64. So it got 64 times bigger. All right, so let's look at a couple problems with this. So first of all, I want to talk to you all about whether if we have area, we square the change. So let's say it got 3 times as big. So if it got 3 times as big, then the area is going to get 3 squared bigger, which is 9 times bigger. If we set it reduced by 1/3, then we're going to square that number. That would give us 1/9. So here it got 9 times bigger, and here it got 1/9 smaller. Now the second one here has to do with volume, and when we talk about volume, we're going to cube these measures, okay? So the change here, so again, say every length got 3 times bigger. This time, however, we're going to cube that number. So 3 cubed is 27. So that means it got 27 times bigger. When we talk about, let's say, every dimension got 1/3, got smaller by 1/3. So again, we're going to cube this measure. This time we know that 1 times 1 times 1 is 1. We know that 3 times 3 is 9, times another 3 is 27. So again, this time it got 27, 1/27 times smaller. So when we talk about area, we square the change. So if it said it got twice as big, 3 times as big, 4 times as big, or it was halved or it was third, then that's what we do. We basically square the number. When we're down here with volume, we cube the change. So if we said it got quadrupled, then we would do 4 cubed. If we said it got 1/5 smaller, we would do 1/5 to the third. So let's look at a couple more problems here and work these out. So it says here, if the radius and height of a cylinder are doubled, describe the effect on volume. I want to notice, first of all, that it's volume that we're talking about, because it's saying that we double it in its volume, we're going to cube it. So that's going to be 8. So it means it's got 8 times bigger. So we're always going to look at these words here. Are we talking about volume or are we talking about area? So let's look at the next one. So the next one says the dimensions of a regular prism are multiplied. Now we know a prism, again, is represented with volume, okay? So once again, we're going to talk about 3/5 and we're going to cube this. So, because it's volume. So we're going to do 3 cubed over 5 cubed. That's going to give us 27 over 125. Okay, so I want you to go ahead and do the next 2 problems and come back to me when you're done. So if you'll notice this time with this check it out example 3a, it says if the radius of a circle is doubled, what is the effect on the area? So this time we're talking about doubling it, but we're talking about area. So we're going to square the change. So this is going to be 4 times bigger because it's area. So do this problem and then come back to me when you're done. So the dimensions of a cylinder are multiplied by 1/2. What is the effect on the volume? So once again, we see here that it says volume. So we're taking 1/2 and we're going to square that. So cube that because it's volume. So it's 1/2 to the 3rd power. So 1 times 1 times 1 is 1. And 2 times 2 is 4, times another 2 is 8. So this time it's getting 1/8 smaller. Okay, so next what we're going to look at is we're going to look at 3D figures and cross sections. So the first thing I want to do here is show you guys a video of basically about cross sections.
Slicing solid, three-dimensional figures results in different two-dimensional shapes, depending on how you slice them. You cut through a cylinder with a geometric plane parallel to the cylinder's base, the two-dimensional cross-section is inserted. Any way you slice it, you get two-dimensional shapes or three-dimensional figures. When you slice a cylinder from top to bottom that is perpendicular to its base, and look at the cross-section straight on, you get a rectangle. What happens when you slice a square pyramid? If you slice across the pyramid with your plane parallel to the pyramid base, the cross-section is a square. If you slice with your plane perpendicular to the pyramid base, the cross-section is a triangle. Remember, you're slicing a solid, three-dimensional figure with a geometric plane. You can slice in any direction. Just keep in mind that shapes can look different when you look at them from different angles. So orient the cross-section on the geometric plane. Slicing diagonally can produce different shapes, such as an ellipse or a trapezoid. Understanding the two-dimensional shapes that result from slicing solid, three-dimensional figures is important for geometry and hinges.
So when we're talking about cross sections, we're talking about the set of points that two or more figures have in common, and that's their intersection. So when a plane and a three-dimensional figure intersect, the two-dimensional intersection is called a cross section. A three-dimensional figure can have many different types of cross sections depending on how the plane intersects it, and that's what that video was that we just watched. So first of all, we're talking about a cylinder here, and if we cut this cylinder right here, we can see that its cross section is going to be a circle. The next one is we cut the cylinder vertically, and this was in the video. We're going to get a rectangle. This next one is a rectangular prism. Now, if we talk about a rectangular prism and we cut it straight down the middle, then we're going to get another cross section that's a rectangle. And if we cut it horizontally, this one's a square. We could call this a rectangular prism, or we could call it a square prism either, actually. So in this case, we're going to get a square. Now, if we cut this image right here, we cut off this little corner right here, you can actually see what the cross section is going to look like. It's going to look like a triangle. The next one, now this time if we cut it diagonally, we're going to get an oval. That's a slanted cross section. Here again, if we cut this cube, or it could be a rectangular prism, I'm not sure which one it is. I think it's a cube though. Yes, this is a cube up here. So again, we do the cross section of this. Really, if we do the cross section of this vertical or horizontal, we're going to get a square. Now this next one, however, is from one point up here at the top to the bottom point down here on the bottom, and that's going to give us a rectangle. So these are really logical. Now this time we're cutting again straight down here in the corner, and when we do that, we're going to get a rectangle. This one again, we're cutting off the corner over here, so we're going to get a triangle. And that was on a cube. So now I want to talk to you about one more thing. If we rotate a rectangle, and we rotate it all the way around an axis of rotation, so we take this rectangle and we keep rotating it all the way around. We keep rotating it, you will see that we then end with a cylinder. So when you rotate a rectangle 360 degrees, we get a cylinder.